We just looked at one-step conversions. We were converting pints to quarts or dollars to pennies, things we can do in one step. But it turns out there's some conversions that we do are a little more complicated than that. Two examples of that are fractional conversions and what we call multi-step conversions. So in this video, we're going to talk about those two things. How do we convert something that has fractions, and how do we know and convert something when there's multiple steps to the conversion? We're going to start with fractions. And what we're going to do is we're going to convert 23.5 pints per hour and to a something unit of cups per minute. Now, what I like to do is I also like to write, when I've got these fractional units, I like to write them with one on top of the other rather than next to each other, because it really emphasizes we've got the numerator on top, we've got the denominator on the bottom. We're going to follow our same idea here. So we're going to put our starting stuff on the left, we're going to put our ending stuff on the right. But here's something about when we're converting multiple units, is 1 unit equals 1 conversion. We can only convert 1 unit at a time. So if we have 1 unit, we can sometimes get away with 1 conversion. Sometimes it requires more, and those are what we call multi-step, and we'll see those going ahead. But if we're converting 2 units, then we absolutely must have at least 2 conversions. You're not going to convert pints per hour to cups per minute in 1 step. We're just not going to be able to do that. As a result, when we have this, we know we're going to start with at least 2 conversions. And again, there's a chance there's going to be even more, but for now, we're going to start with these 2. So we have to do 1 conversion for each one of these. Let's go ahead and make this first one converting pints into cups. So how are we going to do that? We want pints to go away, so where does it have to go? It has to go down here. 1 on the bottom, 1 on the top cancels out. I want cups, and so I put that here. Now, how did I know I wasn't converting pints to minutes? And the answer is for 2 reasons. One, pints and minutes have nothing to do with each other. They're not interchangeable factors. The other is that pints was on top and cups was on top. I convert 1 unit on top to a different unit on top, not to a unit on the bottom. So now we've got cups and pints. Tempting to put in numbers, but let's hold off and let's make sure we get all of our units properly first before we put in numbers. So now I want to convert hours. Let me do this in a different color. I want to convert hours into minutes. Now, here's where people sometimes get mixed up. They're like, okay, well, I always put the thin one on the bottom, and then I put this one on the top because that's what I want, and that's what we've been used to. But look, I've got hours on the bottom and hours on the bottom. If I take hours on the bottom and multiply by hours on the bottom, do they cancel? And the answer is no. I need 1 on top and 1 on the bottom. So here, since I've got hours on the bottom, I need hours on the top up here. 1 on bottom cancels 1 on top. Minutes, I want that on the bottom, right? Because in the end, it's cups per minute, and so minutes is on the bottom. So I already have it where I want it to be, and I've got that. The only units left I have are cups per minute, and so I do get the proper units out of this. Now I can put in numbers. We know that there's 2 cups in a pint. That 2 and the cups are linked together, so that's 2 cups in 1 pint. And we know that there are 60 minutes in an hour. The 60 and the minutes are linked together, and so I get 60 minutes here in 1 hour. How would I put that into my calculator? I'm just going to do 23.5 times 2 divided by 60. Let's go ahead and do that. So we get 23.5, and we're going to multiply times 2, and we're going to divide by 60. And when we hit enter, we get a wrong number because I didn't look at my calculator first. And notice that there was a pi 3, right? When your calculator is doing funny things, sometimes it has some old numbers up there. So I'm going to do it again, 23.5, and then I'm going to multiply by 2, and then I'm going to divide by 60, and it looks something like that. That looks a little bit better, and I get the answer of 0.7833333333. What do we do next? We remember that we now have to do our significant figures. We've got 3 significant figures up here. Cups and pints, a definition, exact. Hours and minutes, a definition, exact. So our 3 sig figs at the beginning is going to be 3 sig figs at the end. And this is 0.783 cups per minute. So that's how we do fractional conversions. 1 unit at a time, not 2 units. You're not going to convert pints per hour. Never in this class going to have a conversion factor where you have something like that, where you have 2 units in the numerator and 2 units. Just never going to happen. 1 unit in the numerator, 1 unit in the denominator, and it's always going to look something like that. So just be aware of that when you're doing these kind of conversions. How about multi-step conversions? What are we going to do? Well, multi-step conversions are where when we try to do it in one step, we fail. And that's fine. The thing people don't know about most science is about failure, learning from those failures, and then eventually succeeding. So when you try something and it doesn't work, it's not because you're not doing the science right. Trying something and have it not work is what science is, but you learn from it, and then you try it maybe better or different the next time. And sometimes it takes us quite a few tries to get something right, and that's okay. So what we're going to do is we're going to convert 1.45 times 10 to the 5th inches into miles. Some people get very intimidated by having scientific notation as part of their numbers, but remember the numbers part's easy. The numbers part, you literally just type it into your calculator and have your calculator do all the work for you. The hard part is getting it set up right and making sure you have the units where you need the units to be and the numbers attached in the right places. So I'm going to set this up just like I would any other conversion. 1.45 times 10 to the 5th inches, and I want to convert that into miles. And if you're just kind of going along, you might be going along, you'd be like, okay, I've learned this now. Inches on top, inches on bottom cancels, and I get miles on the top. And then you're going to stop and try to put a number there, and you're like, how many miles, inches, miles, inch? I have no idea how many inches there are in a mile and miles in an inch. But what do I know? I know a little bit here about inches, feet, and miles. That's an indicator that maybe you've got a multi-step conversion, one that can't be done in a single step, as I've got no way of converting directly from what I started with to what I ended with. And whenever you've got a multi-step conversion, what you also want to have is a plan. And a plan just says, I'm going to go from this unit to this unit to this unit, and then you're going to implement that plan as an actual conversion. So here I'm starting with inches, and I want to know, what am I going to convert inches into? Well, the given information up here tells me that the only thing that I know how to convert inches into is to a foot. So even if I'm not sure if that's the right path, I'm going to take that path because it's the only path available to me at the moment. And we'll see if it works out in the end. Remember, science is ugly sometimes. So what are we going to do next? We have feet, and we're trying to get to miles, and lo and behold, we can convert feet into miles, and we get something that looks just like that. Inches to feet to miles. All right, so what is that going to look like? Now that we've got the plan in place, we're going to be doing something where we put the conversion into place. And the conversion is each arrow is a conversion factor. So we're going to start by putting our 1.45 times 10 to the 5th inches. And we're going to put one conversion factor for the first arrow, a second conversion factor for the second arrow. In the first conversion factor, we're just going to be doing this part here. We're going to be converting inches into feet. So here we've got inches on the top. Inches going to go on the bottom there. One on top, one on bottom cancels. And feet go on the top there. And we've got this whole English thing between foot and feet. We don't worry about plurals too much in our units when we're doing these conversion factors. So that's our first one. And our second one, we're trying to convert foot into miles. Remember, we don't want feet and when we're done. So since I had a foot on top over here, I'm going to cancel it out with a foot on the bottom over here. And I'm trying to get to miles, and so it looks something like this. And when we do all that work out, we end up canceling out inches, canceling out feet, and we do end up with miles, which is what we want. Now we can put in numbers into these conversion factors. We know that there are 12 inches in a foot. Those 12 and inch are connected to each other, so they always stay no matter where they are. This other one I got to look up because I don't know what it is. We've got 5,280 feet in a mile. Where does that 5,280 go? It's going to go attached to feet, which is 5,280 down there, and it looks like that. So how does that go into our calculator? 1.45 times 10 to the 5th inches, divide by 12, divide by 5280. Everything on the top gets a multiply, everything on the bottom gets a divide, and we generally ignore the ones. So I'm going to go ahead and stick that into my calculator right now, and I've got 1.45. Do you remember how to enter in scientific notation into your calculator? We're going to use the e function. So I press second, then I press the EE, then I press the 5. And then I'm going to divide by the 12, and I'm going to divide by the 5,280, and press enter on my calculator. And it's going to give me a number like 2.2885, 2885. And is that what I want at the end? Remember, what do I have to do? I have to check my sig figs. Here, this guy, I've got 3 sig figs. Foot in inches is exact. Foot in miles is exact. And so I want 3 sig figs at the end. I draw a box, and I get 2.2. I want to round up because I've got an 8 there. 2.29 miles is what I get out of there. All right. So that is what we do when we do our multi-step conversions, is we put together a plan. Just the units, just inches to feet to miles. Then we follow that plan when we put together our conversion factor, and we cancel the units and make sure we get the units that we want. So let's do another example. Here it's going to be a little bit more word problem-like. And when a word problem looks like a conversion, the first thing you want to do is try to extract as much information as you can from the problem. And when you see phrases like per, or each, or inna, they're often indicating that that is a conversion factor. And the conversion factors are not usually our starting information. We usually said that we start with 1 unit, end with 1 unit is kind of the most common thing. And those things that have 2 units are generally what helps us convert from one to the other. So sometimes conversions involving time and things like that aren't given, but I do expect you to know how many minutes there are in an hour, how many seconds in a minute, and things like that. And so that's why I don't give them to you. Units like mass or volume, when they're requested as an answer, instead of specific things like milliliters or grams, you get to choose. You get to choose whatever is most convenient. And that's usually a unit that you already have in the problem somewhere. So if you already have milliliters in the problem somewhere and you're asked to find a volume, find it in milliliters. But if you have milliliters in a problem and you're asked to find liters, then you'll also need to do that conversion. And we'll talk about those later on. So here's a problem we're going to practice on. It says, on average, I receive 7 pieces of mail in a day. There are 4 pieces of paper per envelope, and each piece of paper weighs 4.5 grams. What mass of paper is received in the mail in an average year? There's a lot of information in here. It can be a lot to know where to start. So let's go through and extract the information, put it into formulas, and see if that helps us kind of isolate what we want here. So 7 envelopes in a day. That's usually what we mean by an equality. And a day is 1 day. So we get 7 envelopes equals 1 day. 4 pieces of paper per envelope. Okay, so that's another indicator that we have an equality sign. 4 pieces of paper in 1 envelope. And it looks something like that. And then each piece of paper weighs 4.5. Each is also an indicator usually of an equality. So we get 4.5 grams of paper for 1 piece of paper. Okay, so there we go. We've got information we extracted from the problem. Now the question is, what are we starting with and what are we trying to end with? And that's usually the thing that has the question mark on it. Here, what mass of paper? Well, mass, what is mass in? Mass is in grams. So we're trying to find grams of paper is received in the mail in an average year. Well, average year, what are we starting with? We're starting with the concept of a year, and we're trying to get to the concept of grams of paper. How are we going to do that? Well, you might be like, well, I've got this conversion factor that's got grams of paper, so I just use that. But the other side of that conversion factor is pieces of paper, which doesn't help us too much. So that's where we recognize that we've got a multi-step conversion, and we're going to make a plan. What are we going to do to a year? like, I don't know, what can I do to a year? And sometimes that happens. Sometimes we get to the point where we're like, we don't know what to do with this conversion factor. And it's okay in that point to try to work backwards. So I'm going to do that as an example here. I'm going to work backwards and see what I can do backwards. What can I do with grams of paper? Well, now that I've got all my information circled up here, or written down up here, I can look and be like, which of these contains information on grams of paper? And it turns out it's only this last one. And grams of paper, the only thing I know how to convert that into is pieces of paper. So I know that before I get grams of paper, I'm going to have to do pieces of paper, because that's the only conversion that I have. Well, we've used this one now, so we're not going to use it again. Because if we use it again, we undo what we just did. So I'm going to cross it out. Like, hey, I'm not going to use that one anymore. But I've got pieces of paper. What am I going to do with pieces of paper? I don't know. This is so confusing. But you look at what you have available to you, and there's only one conversion factor, one conversion equality that talks about pieces of paper, and that's this one here. And the thing it converts into is envelopes. I'm going to run out of space here. Is envelopes. Right? Now, I use it, and I'm going to cross it out. I don't want to use it again. What am I going to do? Envelopes. Well, the only thing that talks about envelopes converts to days. And oh, if you remember, years out here. Do I know how to convert years to days? I do. And so now I've got this little bit of plan. I worked on it backwards on purpose here, but I could have also guessed going forward. I could have guessed that, oh, you know, I've got days, so let me convert years to days, and then days would convert me to envelopes from this conversion factor here, and then envelopes would have converted me to paper from here, and then paper would have converted me to grams of paper here. But now we've got our plan, and now we're going to implement that plan. So how we implement the plan is we get one conversion factor per arrow. So here we've got 1 year, and we got 1, 2, 3, 4 conversion factors in this problem. Whoa, that's a lot. So 1, 2, 3, and 4 conversion factors in this problem. For number 1, we're going from years to days. We want to get rid of years, so it's got to go on the bottom, right? 1 on top, 1 on the bottom is how you cancel things. And my thing up here tells me that I'm trying to convert that to days. That's how I know how to put days in there. Number 2, I don't want days anymore. I'm trying to get rid of it. So I've got 1 on top, 1 on bottom is going to cancel out like that. Step 2 up here tells me I'm trying to convert this to envelopes. And you know, my envelopes went a little out of my parentheses here, and that's okay, because we're trying to guess things and plan things, and occasionally it doesn't fit, and that's just fine. It doesn't have to be perfect. I know the perfectionists among you want it to be perfect, but it doesn't have to be, especially on your first try. All right, we're now over to step number 3 here, and that is envelopes to pieces of paper. We know that envelopes is going to go down here, and pieces of paper must go up here, because that's the only place for it to go. Why does envelopes has to go on the bottom? Because 1 on top cancels 1 on the bottom. Step 4, we know we're going pieces of paper to grams of paper. What's got to go on the bottom? We got to cancel pieces of paper, right? We don't want it. That's not what we're looking for at the end. And so it looks like that. And then on the top is grams of paper. So now we have, woohoo, a bunch of conversions. Still no numbers yet. We worked on the units first. Everything canceled the way we thought it would. The only unit left here is grams of paper, which is what the problem's looking for. Now we put in numbers. Days and years. We know there's 365 days in a year. That 365 is attached to days, so no matter where days was, I would keep them attached to each other. 365 days in 1 year. Envelopes and days, if you look back at our numbers, we got 7 envelopes in 1 day. 7 is connected to envelopes, 1 is attached to days. Pieces of paper and envelopes, there were 4 pieces of paper in 1 envelope. And grams of paper and pieces of paper, there was 4.5 grams of paper in 1 piece of paper. This is pretty simple to enter into your calculator since they're all multiplies. You'd put in 365 times 7 times 4 times 4.5, and your calculator should give you, should I write down the number here, 45,000 900 grams of paper. Now, are we done? We did our work. The last thing we need to do is check sig figs. This one's a little hard, so we're going to kind of fudge it a little bit. But it turns out this is probably what going to be limited by. Envelopes we can't count, so that's exact. Pieces of paper we count, so that's exact. 365 days, that's a definition, it's exact. The only one we fudge a little is 1 year, but chances are we know that to a few digits because we know we're not a year and a month. We know we're not a year and 2 months. We're saying 1 year is relatively exact in this case. So 4.5 grams of paper, we certainly could measure that one better. We have 2 sig figs available to ourselves. We're going to say 46,000 grams of paper is how we'd solve this relatively complicated multi-step conversion. Make a plan, do the units, get your numbers last. Thank you.